conference, and it gives me great pleasure to introduce the keynote for this session, Professor Pirjo Aunio, an outstanding scholar and fantastic collaborator whose work I greatly admire. I had the pleasure of working with her as a SIG 15 coordinator a few years ago, and also was able to visit her lab earlier in the autumn. Professor Pirjo Aunio started her career at the University of Helsinki in Finland, where she first completed a degree in teaching, after which she completed her PhD in special education in 2006. Since 2009, she has been, and still is so, a docent and full professor in special education at the University of Helsinki. But Professor Aunio also likes to spread her wings, as she's been a visiting professor at many different universities, including the University of Oslo in Norway, the Nanyang Technological University in Singapore, and she is currently a visiting professor in early childhood education at the University of Johannesburg in South Africa. She's been an early member for many years and a significant contributor to the early community. Her research focuses on the development and learning of mathematical skills, learning difficulties in mathematics, importantly the assessment of mathematical performance and development, and mathematical interventions. She has done unique work in developing evidence-based assessment and intervention tools that can be used by teachers with funding from the Ministry of Education and Culture. She has published more than 60 peer-reviewed articles and books related to her research area. She's a member of editorial board for 3 international scientific journals, including Learning and Individual Differences, and she regularly reviews for other journals as well. Her research projects have been funded by various funding bodies, including from the Finnish Ministry of Education and Culture and National Sports Science Council, to examine the developmental dynamics and interaction between motor and early numeracy skills in 3 to 5-year-old children. Today, she will present evidence from various longitudinal and intervention studies to provide insight on how young children learn early numeracy and possible learning difficulties in her keynote titled Individual Differences in Early Numeracy, Executive Functions, Motor Skills and Physical Activity. Please welcome to the stage Professor Pirjo Aunio.
Good morning, everybody. Thank you, Joe, for a very nice introduction. It's a pleasure to be here. Of course, it's an honor, a big honor, and I hope I can entertain you for an hour or less about what we have done. And my topic today is individual differences in early numeracy, executive function, fundamental motor skills, and physical activity. And that's what I try to focus on and not go some other side paths, which I often tend to do. So my viewpoint today comes from the special education, as that is the field of my professorship in University of Helsinki, and probably why I'm here today is the background in SIG 15, special educational needs. I ended up with this field by accident, but there was a motivation for me is that I always was puzzled and why it was so hard for some children to learn, and for some children it was much easier. It was during my master studies that I ended up deciding that, okay, I need to do something about it. And I think that the field of special education is something that provides enough challenges for me, because there is a need to understand average performance and also the development, but also the development and learning in not average performing children. And it also includes fascinating job of identifying children with learning disabilities. I find it fascinating because we don't have tools for that one. And one other point that is important for me is that we really need to support children, and that needs to be done well. So we need intervention or that kind of thinking in our work. And on top of that the field of special education provides me and my colleagues a possibility to study theory and contribute on theory, but also to educational practice. And fantastic to be a Finnish person is that there is lots to do. We don't have assessment tools in Finnish and Swedish in all where we want them to be. And so there is this is a never-ending story in a sense. Our job never ends. But a little bit about my background still. This is where all it started. I was a young student, I'm only old professor already, but then about 25 years ago I started my PhD, and from there I have kind of been stuck with the idea that we need to develop evidence-based measurements. That was one of my papers in my PhD. And then we have to predict later development. And then we have to do something if we find children who struggle with learning. So this is my circle. Again, I already showed it on another symposia, but this probably helps you to follow my thinking. So in special education, I see this as an important thing. You have to understand learning and development, and then you can design assessment tools. And if you then are able to find a good tool to identify children with learning difficulties, then you will have a step to provide them help, and that's intervention. But this is a never-ending story, because no tool, no intervention program is perfect. There is always something to do better. And that's the circle I'm still dancing every day, every morning and every evening. But it's fun. And I really like it. So some interview was made and asked why I'm not in the field of in a psychology field, so developmental psychology or something like that. I thought, why on earth? Then I couldn't do anything for the children. Sorry for all developmental scientists. But that's, it's important for me to have an impact on children's life. This is something what our research group is doing still, and I have been doing a long time. It is a study about young children's mathematical learning and focusing skills that are important for later learning. We have published a model for core mathematical skills in 2016 to be able to describe what kind of skills are most important in children's development. Today, I'm talking about early numeracy factor mostly. That includes early mathematical logical principles, knowledge of number symbols, number word sequence, enumeration or counting if you like, and very basic addition and subtraction skills. In some of the studies I present today, we also have symbolic magnitude processing measured and mathematical problem-solving items as well. 2019, I got interested how non-active lifestyle of kids affects children's learning. Hence, the physical activity and fundamental motor skills, running, jumping, throwing, balancing, got into my scope. And even though I'm wearing black today, my favorite color is pink, so you can see what is the focus of today. So why on earth do you do a study that combines something like that is early numeracy, executive functions, fundamental motor skills and physical activity? Why don't you just stick in with early numeracy? It's easier. I can probably handle it quite well. Come some points that I want to make. There is a strong evidence that early numeracy will predict later academic performance, including, for example, mathematics and language performance. There is also good evidence that there is no one skill developing, but several skills that are important for later mathematics learning. However, we are still seeking for evidence of timing of learning and which one of the skills are the most important predictors. We know from older children that domain general factors like executive functions, language skills are related to mathematical skills. But we have less evidence concerning very young children, meaning now early childhood education. Interestingly, we lack knowledge how other domain-specific factors like physical activity and fundamental motor skills affect early numeracy learning in early childhood. We talk about holistic approach of children learning and doing learning studies, but we still do research in silos. Sorry guys, this is the truth. But there is a tendency to widen up. There is a lot of groups here also present, studies that they do combine other skills as well, and I think that's quite a promising approach. If we really want to support young children's learning, we can't do it in silos. So I kind of invite people to do open-minded studies. It's fun at least and challenging, I guarantee that one. We also know that early numeracy intervention can be effect on performance right after intervention. We have quite solid evidence of that. But seldom we have seen long-standing effects. It means that the effects of intervention fades. So I started to think if it's possible to use other domain-specific skills to support early numeracy learning in early childhood education. A couple of years ago, there was a heated discussion and public concern still related to increase in non-active lifestyle of children. And that means only little physical activity and low intensity in that activity. And then there was also concern of decreasing fundamental motor skills. So children were thought to be clumsier in that sense. Results, especially from the field of sport sciences, have demonstrated that physical activity and fundamental motor skills are linked to school achievements, especially mathematical performance. We have also results showing that physical activity and cognitive development are related in school-age children. One framework for understanding motor cognition link is based on neuroimaging research. Relying on that, we think that the link between physical activity, fundamental motor skills, cognitive skills, and academic skills is mediated through enhanced angiogenesis, increased oxygen saturation, and glucose delivery, improved cerebral blood flow, and increased neurotransmitter levels. So really on brain stuff. The effects of physical activity interventions have seen in changes in structural brain volumes and brain functioning. So there seems to be evidence that maybe there is something in the fact that physical activity, motor skills, and cognition can be related in brain level as well. And cognitive variables often in these studies are measured in the means of executive functions. The association has been found also between fundamental motor skills and cognitive skills. However, there has less studies involving young children and early childhood education where development of basic skills is quite fast. This is quite surprising. There is also a lack of longitudinal design with objective measures. I mean that often, and when the research has done focusing on young children, it relies on teacher questionnaire or parent questionnaires. But no one, or not very many, really measure children in there. In addition, there was no intervention study showing how effective interventions combining physical activity, fundamental motor skills, and early numeracy learning are in early childhood. That's what we were trying to do. So in our active early numeracy study, which started 2019, we designed to study individual differences in early numeracy, executive function, and motor skills, and physical activity. In my talk, I will show our cross-sectional results from the structure of early numeracy in 3 and 4-year-old. Then I will show some fresh results from longitudinal analysis, and after that I describe our work where we developed the intervention program. But before I go to the results, I would like to show you the measurements that we have been using, because I think that this might ease up your possibilities to follow my talk. So physical activity is measured with objective measure. The children were using the accelerometers and for 7 days, and they put them on when they woke up, and then they took them off when they went to bed in the evening. And we used cutoff scores to separate the levels, which I will explain later on. But here I think it's good to, if you are doing the study with this kind of equipments, it's nice to probably hear the hint that we heard as well, was that, that we also gave a story for the kids that they were superheroes and they were collecting energy for one person who needed that energy. So the more they did and reserved energy for that porcupine, then the better it was. So they were motivated with that superhero story, which was quite a success. So our group juniors take all the credit of creating that story and delivering the kids, but that was a good job. So physical activity was measured, and then we measured fundamental motor skills, which can be divided to locomotor and object control skills and stability skills. And we in these studies we use sometimes part of them, sometimes all of them. And executive functions where we focused on working memory and updating and inhibition and switching. And for working memory we have a pictorial updating task, and then flanker for inhibition and switching, simultaneous and Mickey inhibition task as well. So 3 and 1 set of tasks. This was computerized, and all the measurements were done in preschools. And the one measurement was early numeracy test. This was the one that I did during my PhD thesis. So this was an originally Dutch measurement done by Professor Van Luit, also a member of EARLI. I met him in EARLI conference, so EARLI conference can be really important for your career. At least it was for me, because Johannes Van Luit is one of my supervisors and still a very dear friend. So collaborate with EARLI members, that's beneficial. Early numeracy test has 40 items. We divide them to numerical relational skills, which have 20 items, and counting skills with 20 items. And the maximum is 40 items if we use the whole scale. And then we have invented a new measurement, which is mathematical problem solving tasks. We have 21 items that we ask children. We have a lot of pictures. We have materials to ask them questions. Idea is to tap on mathematical problem solving and try to really find out their problem solving skills. It was done by our group because it was non-existent for this age group. So I think that we published one paper this summer. Yes, one of the PhD students is saying yes. I think it came in June. Yes. That's good that somebody knows what happens in our group. And then we used so symbolic magnitude processing. Even though this scale was done for elementary school children, we did it with younger kids. We measured it in a way that it was an interview, and the tester scored the results, meaning that we didn't use the time, we used the accuracy in this test. So this is a paper that I know that I submitted last week, so I know something. So this is also quite fresh. thing, and this was done because research on preschoolers has largely focused on 5 and 6 years old. And in younger children often collapses across different age groups. So we don't necessarily know what the 3 years old know. We know that what the 3 to 5 years old know, and that's not the same. So we wanted to measure young children's early numeracy, and we wanted to see if the test that has been used with older kids was usable also with younger kids. And we have here 3 years old we have 147, and 4-year-olds we have 173. And we investigated first the reliability and validity evidence, and then we investigated the role of family variables, language skills in individual differences early numeracy. Our results show that early number test can be used reliably, measure numerical relational skill in 3 years old, and numerical relational and counting skills in 4 years old. Furthermore, 3-year-old children's numerical relational skills were significantly related to symbolic magnitude processing. And also in 4 years old, both numerical relational and counting skills were related to symbolic magnitude processing. This provides nice evidence that the constructability of early numeracy test. When analyzing the individual differences, we found that in both age groups, higher numerical relational skills were related to fewer number in children in the family, higher family income, higher parental educational level. In the 4-year-old, higher counting skills were related to having higher parental educational level. However, when including language skills as a mediator in the model, most of the effects of family variables on early numeracy disappeared. So language that I'm sorry I didn't have that measurement here, but it was a basic expressive and receptive language skills that we used here. So that took the power from the family background here. Only parental education level predicted numerical relational skills directly and indirectly through language skills, but only in 4-year-old children. So it tells that family background in these skills for 3 and 4 years old is not so significant as is the language. So I think it's something good to remember. So related to the question about what are important mathematical skills developing in early childhood, we look at the co-development of numerical relational, counting, symbolic magnitude processing, and mathematical problem skills in preschool age. We combined 2 cohorts of data, together 267 children. We measured early numeracy, symbolic magnitude processing, and mathematical problem skills. And this is very fresh, so bear with me. I have to read what I have written, otherwise I start to do some kind of conclusion that my colleagues will later on say, oh stupid you, why did you say that? So I will have what I have written. All measures do correlate positively with each other. So it means that those who do well in counting tasks do well in numerical relational, symbolic magnitude processing, and mathematical problem solving tasks. But their development, so meaning the slope here, do not correlate significantly with each other. So it seems that development is quite independent in these skills and not systematically related to each other. That's, I think, a really interesting result. Almost all performance and development correlations are negative, meaning that those who had lower performance in the beginning developed faster during preschool years than those who had good performance in the beginning. There was one exception here, stated with green color. Mathematical problem solving performance in the beginning was positively correlated with counting skills development. But basically it tells that these skills develop with their own paths without a big interaction with other skills. There is something different in the problem solving skills which is developing, which we'll try to find out later on how what affects on that development. Then we have looked also the longitudinal association between physical activity, fundamental motor skills, executive function, and early numeracy. We measured physical activity with the accelerometers and with 7 days wearing, and we also measured locomotor and object control skills, executive function, inhibition and switching, and working memory and updating. And early numeracy was measured with early numeracy test. We also measured stability, but it has no significant association, so we dropped out from this model. So here we have divided the physical activity in classes, and it means that there can be moderate physical activity and vigorous physical activity. And in a rough sense, the difference is that vigorous physical activity is something that the kids get a little bit short of breath, so they run, that they really make some effort on that activity. So it's clearly more than moderate level. And in our cross-sectional analysis, we already knew that, okay, the moderate level was not so significant for the development, so we dropped it out and concentrated on the vigorous physical activity. And we can see that vigorous physical activity in time point 1 was positively associated with early numeracy in time point 2 via locomotor skills. And locomotor skills time point 1 were associated directly with early numeracy at time point 2, and indirectly via time point 2 updating skills. So they are those colored lines that we have here. It was associated with object control skills in time point 1 and inhibition and switching in time point 2, meaning that vigorous physical activity was related to lower performance in inhibition and switching 1 year later. So our results support the idea that motor skills are related to cognitive and early numeracy skills. The results related to physical activity and executive function and EN learning are less clear. So this goes a little bit against what the sports scientist has kind of reported about 5 or 8 years ago, saying that there is clear links between physical activity and mathematics skills in older age groups. Our data shows that there can be something else happening in kids. It's not necessarily straightforward. So then I turn to our intervention part. We started it with with a review, 2 of them. And as one of the main aims for this research project was to design an intervention program to support the early numeracy development of low-performing children in early childhood education. So we decided first to look at evidence related to physical activity, motor skills intervention designed to have effect on children's cognitive and academic skills. We did one literature research using databases of ERIC, Scopus, Web of Science, PsycInfo, CINAHL, PubMed, and Sport Discuss. And you can see our words, how we word lines were what we searched for. We did it with the PICO framework. And we used preferred reporting items for systematic reviews and meta-analysis, so friends call it PRISMA. We use it PRISMA 2020. There is a new version which should be used if you are doing work at the moment. We also use effective public health practice project quality assessment tool to measure the quality of individual studies to be included in our analysis. This was because I had a critical point to make for existing meta-analysis, which seems to be that there are coming a lot of them and people are putting anything in them and getting something out of them, and then nobody anymore knows that what is reliable and what not. So I kind of needed to, for myself, to be sure that what we put in the machine has some kind of rating of quality. And that's why we use this effective public health practice projects protocol of quality. After the literature search, we realized that there is need to split the reporting. So we first reported average performing kids, and then we reported in a separate paper the studies with children who had special educational needs. But here is our quality rating, and sorry, I'm so finished that I forget always to say that who did this, but these are my colleagues in my research group, so you see the names there, so it's not my work, it's their work, but I'm kind of the one who needs to come here and try to explain what we have done. So in our quality rating, we rated selection bias, study design, confounders, blinding, data collection methods, withdrawals and dropouts. And ratings were either weak, moderate or strong. And for us, a very important thing was to calculate the overall quality. So because we wanted to use it in our second step of analysis. And from here you can see that, you can't see, but I can tell you, there is 35 studies included and only 2 had strong quality. So you already know what we are struggling with. This is our results where we combined the calculated effect sizes for each individual study and put them in a table with the overall quality ratings. And we can see that among these with large effect sizes, the quality studies were weak or moderate. Green is a good quality. So we are doing quite lousy job, colleagues. I think we should do better. In a sense, we have really more red here than green. So what did we take home with this study? Fundamental motor skills and physical activity intervention may support cognitive and academic learning in children. It's possible, it seems. Interventions were effective in children's executive functions, language, numeracy, cognitive skills, and enhancing memory. Combining interventions, so it meant that it had physical activity or fundamental motor skills plus a cognitive or academic skills included. So either something to do with the physical activity and then a little bit academic skill. And they were more effective than only fundamental motor skills and physical activity interventions. So it tells us that intervention should include skill practicing rather than only physical activity in order to gain greatest benefits in early childhood. So now we need to remember that these are very young children that we are talking about. But the problem here is that most of the studies in the systematic review had a low methodological quality and inadequate reporting practices. So it's like, can we trust this? But you have to trust something in life, so let's trust that this is work that we are doing, continuing doing better and better, and with reporting these issues, our science will get better. So we continued with our second step, which was we reported the evidence related to effects of fundamental motor skills and physical activity intervention on cognitive and academic skills in 3 and 7 years old with special educational needs in a separate paper. Here we did an update in our literature review as the search was more than 1 year old. It meant that we needed to do like an update to see that if there had been published something in the meanwhile and do the quality rating as well. So it was an additional job done here as well. And we used exactly the same protocol for reporting as we did in a previous study. And here you can see that the studies that are included in our special ed population review tells you also the same story, 2 studies with strong quality and quite many with not so good quality. And here you see the effects and the quality. Again here, red is bad and green is good. and yellow is in the middle, so you can see that with large effect size we only had one study. So these had some concerns. What we did learn from this one is that fundamental motor skills and physical activity intervention may be beneficial in the support of cognitive and academic skills in children with SEN. The intervention effects appear to be somewhat dependent on the severity of the difficulty. In cognitive and language skills, the intervention effects were largest with children with minor difficulties. Executive function in intervention effects appear to be largest in children with more severe difficulties. And this, I think, clearly shows that it's not possible in the special educational needs studies to put everything in the same box. We have to be able to kind of look deeper and understand deeper what the children are struggling with. In line with these findings from typical developing children, combined intervention appeared to be more effective compared to fundamental motor skills and physical activity only intervention. So combining something sport and something academic is good. The results should be treated with caution here, as well as most of them showed low quality in methods. Then, based on our two systematic reviews, we got a little bit green light in our heads that it might be a good idea to try to develop an intervention program to be used in preschools to support early numeracy learning with early numeracy learning with children who had low performance. And this is why we think we do this because we think that if you are low in preschool, you are probably low in kindergarten, you are probably low in primary school, so we have to do something before it escalates. And that's why we are advocating for early intervention in that sense. Helsinki and Dutch group did publish result that mathematics vocabulary can be supported with intervention that use books that has rich math vocabulary. So a little bit kind of getting ideas from there, we designed an intervention program in which we use storybooks with numerical relation concepts and designed numerical fundamental motor skills activities to participate, to practice these concepts, which means that we try to kind of take the benefit of motor skills practice to support the learning of math concepts and relational skills, especially. This is our first study that we have published about the results. One of my group members is, I think, hopefully next week submitting the next one, no pressure. The aim of this pilot study was to examine the immediate and long-term effects of an intervention program that aims to improve preschoolers' early numeracy skills. And we tried to combine relational skills via storytelling reading with fundamental motor skills practice. And this is the part of the study or our project that COVID-19 hit the worst. So this was, we kind of saved what we could. And we collected 3 small interventions instead of one large one, what was planned. And here is the results of those, one of the studies. This was also a little bit relying on educators' work as we trained and coached the preschool teachers to use our intervention program. We had no access to do it ourselves in that time. And teachers also identify children having low performance in early numeracy, and we also measured those kids, so we had a double check that they were really performing low. The aim was to have 45-minute sessions twice a week for 8 weeks. It means that the total dose was 720 minutes in our program, if you want to compare it to some other programs. And all sessions had same structure: beginning, storytelling, motor skill activity, and conclusion. And here we can see that these results from this small study are quite positive. Children's early numeracy and especially numerical relational skills improved during the intervention. and the intervention had larger effect on children's early numeracy and numerical relational skills compared to control period. So there was no control group. We compared the kids against their previous development, and we saw that those who were in our program developed more than in the baseline. So this is one type of doing intervention if you kind of lose the control possibility. So to sum up, evidence of individual differences in early numeracy, executive function, motor skills and physical activity. Age differences in early numeracy skills that we can and should measure in preschools. It means that especially younger children, we need to think twice what we are measuring and what does it mean that we get some results. So it's not straightforward to take measurement that is designed for the older group to put in the younger group. The evidence needs to be done. And for example, we now know that we will not use early numeracy test with 3 years olds with a total score. We use only relational skills. And related to non-active lifestyle and worry how it is related to young children's learning, we can say that in young children's skills are important, so skills. As fundamental motor skills are more relevant to early numeracy learning than physical activity, amount and intensity in that sense. But physical activity is not irrelevant, as that is also connected to fundamental motor skills development. But it seems to be less important to mathematical development than is the skills development. In early childhood education, it is recommended not to put children run around in the building, so just increasing the kind of doing high intensity, but probably it would be wiser to concentrate on the skills. So how to run, how to climb, how to stabilize, how to throw a ball, how to hit the ball. Those are skills that are very fundamental for children's learning, and probably, at least based on our evidence, shows that it probably supports other skills learning as well. So framework based on neuropsychological evidence seems to be supported with our evidence. And of course there is competing frameworks as well with, for example, the automaticity. But we can see that executive function still stays as a potential mediator variable between fundamental motor skills and early numeracy learning. So it has a role there. That can imply that interventions combining fundamental motor skills and early numeracy skills in practice can have effect also to other factors of learning, for instance, language. But we need to test that later on. Our experience shows that we especially need better reporting practices, and so that the replication of the studies is possible, and it's possible to do, for example, systematic literature reviews, and they become more valuable. For the educational intervention practice, our study has produced evidence that in preschool it is possible to support low early numeracy performance with combining this motor skills practice. I think it's fun, because in a sense it tells that those old ages, early childhood educators, at least in Finland, who tried to get kids to ski and skate during the winter, and who tried to kind of mobilize them as much as they can, they were kind of right. That was something that was good for the child's development in that sense as well. So I would like to thumbs up those all early childhood educators who do the tough job and do what they can and have been doing very well so far. Where we are heading from here in our project, this relates to Ansari's yesterday presentation. He was talking about that the evidence comes from weird populations and not from other part of the world. I'm happy to tell that we are doing exactly the same kind of study at the moment in South Africa, so we will get data from there. Hopefully already in next early I can present some longitudinal evidence from there. Of course, it's a little bit challenging to do studies with such a huge population, but we are trying. And we have done so far already some studies, and we find that early numeracy skills are quite similar, even though there is developmental differences in skills level. There is not necessarily difference in quality of development between South African and Finnish children. But we need to, of course, publish that paper first before we can say anything about it. But it seems to be that way. So weird populations are coming up in that sense. So before I stop, I want to thank my active numeracy research team, and which have done most of the work. I have been doing something else. And our international collaborators, we wouldn't be here without Kerili's kind of support for our group, as well as Berthe Smets has provided us a lot of support and fun time doing research together. And of course, the city and the preschools and the kids and the parents and all those who were struggling with COVID restrictions, they were still accepting us to the preschool. Just to, I'm not a crying person, but this is a huge thing. We had still almost 21 kindergartens in the city of Helsinki when we started. We had 500 kids. We had 10 research assistants going every day to the preschools, being there the whole day, doing the measurements. Measurement time for each kid was 2 hours and a half for each measurement time. That's multiply 3 with an intervention. So you can understand that they did a lot of work, our group, but the preschool teacher as well, because they allowed us to go there. So it was an honor that they, like City of Helsinki said that they want our study to be done, and so they did. So a great thanks for them. And we are eager to collaborate, of course. So if you want to collaborate with or want to know more, please send a message and we'll look what we can do together. Thank you.
Thank you very much, Professor Aunio. If you have any questions, please raise your hands, and I think our volunteers with the blue t-shirt will come to you.
I'm asking you for an opinion about basically the linkage between what you said about motor skills and academic skills, cognitive skills. My impression is that there's very little theoretical understanding in how basically these two are linked. And that's the studies you presented. Maybe the results may be due to a very poor methodology, but it also may be due to a very poor understanding in how basically these motor skills and academic skills are interacting. So when it comes to the question in the classroom, what do you want to do as an activity? When do you want to do it? How often do you want to do it? There is basically not a very sufficient answer. And I think a lot of it relates to what I said, to the problem that there is very little theoretical grounding on this linkage. So in order to better understand how these are linked, I think we need much more empirical evidence that draws to developmental science, to neuroscience, to also movement science. And I think based on very collaborative and interdisciplinary work, I think we could find these answers and could provide much better suggestions also for schools.
Yeah, I agree with you totally. We don't know why this link exists, but my point of view here is that before I go to to study why, I have to know if it all exists at all. So, and how it, like looking, trying to tap that where it is and where it's not. And I a little bit disagree with you that there is no evidence because, for example, Hillman's group and Stoden's group have provided evidence that there is a link, and then they link it with the neuroimaging results. But I agree with you that it's not strong and it's very versatile, and I would like to know more myself.
I agree with you that there is kind of hints,
yeah.
But most of this work is correlational.
Yes.
So that it's not causal.
Yeah.
And that's, I think, a big issue here.
Yeah.
Because what we want to say is that physical activity is actually influencing in a sufficient way, in a fundamental way, cognitive functions.
Yeah. And if I may comment here, I think that our results show that it's not the physical activity, but it's the skills that the children are using when they are doing the physical activity. That's not to say that physical activity and motor skills are like separate ones, but our results show that it's in young children it is more the linkage comes from the skills level and skills learning. There is something common. And then the physical activity is a little bit on the side based on our study.
Let's move to a different question. It was a great question to ask. There was people in the back as well having their hand up first. Sorry, we'll come back to you.
Hi, thank you for the wonderful presentation. My question is actually related to this because when it comes to that relationship between motor activity and the skills of the children, I wonder whether you have made any observations of the children while they were engaging in physical activity. For example, did children who engaged in physical activity spontaneously also engage in mathematical or pre-mathematical activities, such as counting how many times you can kick the ball high, or seeing how many tiles you can skip or jumping?
Thank you for your question. I fully agree that is needed. We in this project we had no resources to do it, but it's one of the plans to go to preschool and look what the children are really doing there. So either taking videos or some kind of other tracking system to know exactly. Try to find out that one.
So the one question with the gentleman with the glasses and the brown t-shirt behind you on the left-hand side, and then one to the right-hand side here.
Thank you very much for the exciting work that you're doing. I was quite puzzled by the finding in your longitudinal study that basic numerical skills are correlated in the beginning, but that the trajectory, the path of development is not correlated between those. What do you make out of that? First question. And the second one, what would it mean for intervention and transfer effect?
Well, I have to say that these results we got out last week or 2 weeks ago, so we haven't been able to kind of think and test several of those, but of course this is the model, but for me it tells that in young age probably there is we tend to think that mathematics go by steps, that you kind of go straight forward, but I think this tells that it can be so that some children are proceeding with counting skills quite heavily, but not doing anything on relational skills, meaning that those comparison, one-to-one correspondence, serialization thing. So it kind of tells that we had the tendency to put everything together and say this is early numeracy, right? But I think that I agree with Devlin's work in a sense, saying that this is not probably the best way, and we probably need to look better on our models, how early numeracy develop and what are the skills really developing. But I think that I would like to answer your second question about the intervention effects and transfer. So because I translated in a way that what should we then put in an intervention, right? So looking at from the special educational perspective, I would try to find out that what is the weakest point of the child and target the interventions on those and build on that sense.
Excellent, thank you.
We had a question from the lady. Oh. Did you still want to go, Chiara? Yeah, okay. Wait for your microphone maybe. And then there was another question in the section. Thank you.
Thank you for your talk and your work. You made me think to children with congenital cerebral palsy because there is a kind of disorder that is diplegia, where although the lesion is very posterior and the intelligence is normal, at least at the beginning, they develop important difficulties in math, especially in math. So my question is whether if you think that in these children with diplegia we could try to overcome the physical activity that mostly they cannot do by trying to either work on executive function, if they could be a mediator, or try to develop exercises that, as you said, work on the skills, on the fundamental motor skills, although not by physical activity.
Thank you for an important question. I have to say that we didn't have an atypical students in or children in here, so this is like speculation what I'm now doing. But I want to also kind of underline the fact that even though we planned, we were not able to test the hypothesis that we had interventions. So one intervention having motor skills and math in, then we had one intervention having only math in, and then we had one intervention having only motor skills in. And we have not yet able to do it because of the COVID. But that might help me to answer your question, that because I want to find out later on that if this that we put together motor skills and early, for example, early numeracy training is better than early numeracy training alone. So that would kind of point to your question that do we at all need to think about that we should have motor skills development involved in those interventions that are put in that group. So we need more evidence on knowing that competing the intervention against each other.
There was a question in the middle. Yeah.
Thank you so much for this keynote. I feel like I've been waiting for something like this for years. So actually I have a lot of questions, but I'm going to talk to you, I guess, later. So I just wanted to say something first and then the question. So I was trying in my research to also look at the relationship between motor skills and math, or basic math skills. And I've been trying to explain this through embodied cognition, and also a little bit through the sensory motor phase that Piaget postulated. And so now my question, I've been seeing much more the relationship between fine motor skills and math than gross motor skills. But that doesn't mean that gross motor skills are not important. So I wanted to ask you what you saw in your data. Do you see like a relationship, and what is it exactly? Do you do the difference? Like, do you look at the difference between fine and gross motor skills and their relation to early numeracy skills?
Thank you very much for your kind words, and you tapped one of the things that I have not yet done. So if there is a PhD who want to be and want to come and do, we have a data with fine motor skills as well. So that's exactly what we want to test in our longitudinal sample, that which one is then more important, because there is a lot, as you said, there's a lot of evidence that the fine motor skills are related to cognitive and academic learning, but less about the gross-motor skills or fundamental motor skills. We have a possibility to test that hypothesis when we get home, so I get back to you when I have the results from that. But that's nice to hear that you have been puzzling with the same issue.
Thank you very much for this fascinating talk. I would like to, I had exactly the same question that the person just before. What about embodied cognition? Because it seems to me that would be a good frame or a good theory to try to explain theoretically the relationships you have between the gross motor skills and early numeracy. I mean, probably it's not complete, it's not perfect, but maybe it would be a good frame to do so. What do you think about that?
Thank you for the question. This is a tricky one. Embodied cognition, the work that has been done previously, have not convinced me that I would be able to do the hypothesis that I would be able to test with this kind of longitudinal design. So there, maybe it's me, maybe it's my ability to read the work. For me, it's kind of too much in there. So it's kind of they put everything in, and for me it's hard to understand what is the most important. So that's what I like. For me has been puzzling to make any kind of hypothesis that I could test. And I'm really a tester in a sense that I would like to convince first myself and then the other ones that there is something. Yeah. But probably there is something I should read more. Thank you.
Can you hear me now? Okay. So it's more a statement than a question. I, many years ago, did some health psychology research, and we were looking at physical activity in the border of Texas and obesity, but it kind of goes to, I think, a question that was too before about looking at like the normal everyday activity that a child uses and how can you measure that. We used a device called SOFIT, which is a system for observing fitness instruction time. I don't know if you're familiar with that. We use that. It requires a lot of training to use this observation tool, but it might be a way for you to observe normal activity, and it puts it in these scales. It's really good just to look at that. And I was thinking, because part of this program that I was doing an evaluation for was also looking at nutrition. I mean, you're throwing in another aspect in here, but I'm wondering if that is also something that might be related as well to, like, of course, the development, cognitive math skills, and so forth.
Thank you. If I may comment back, I think thank you for the hint. We'll look for it. But the nutrition is of course important, but that would then mean that again a little bit bigger project in that sense. But I think it's we have results from Brazil, for example, that there is the nutrition and the way the children grow up is important. So I think it's especially if we look at the non-weird populations, so meaning those outside our Western world lifestyle, and possibilities. So I think it's something to look at. This is probably the hardest question. Promise to be kind.
Thank you very much for an excellent talk. Listening to some of the questions made me think about at a Diamond's review, looking at physical activities versus physical activities plus, and the impact on the development of executive functioning. So I was thinking of that slide you had about with the accelerometer.
Yeah.
So that provides us with a really good measure of physical activity. But if we go back to Diamond's conclusion saying that it's not physical activities per se, that seems to be producing some of these improvements. It is physical activity plus engaging in a cognitive level. I think the example she gave was even with running, for normal mortals, when you go out for a run, you switch off, right? Whereas for your athletes, you're thinking about how to move most efficiently. So each step you take, you're thinking about some of these things. And that seems to me a challenge to the field as to, okay, how do we measure physical activity plus whether our kids are also engaging cognitively during those activities. Any thoughts?
Our results show actually that the stability task is one of the best predictors if we look them separately. So it taps right into your point in that it's not necessary. So that's what I'm trying. What in my mind it goes with the skills thinking, that there is something in skills training that is needed for the physical activity, but still it's something more. And that's why I think that executive function still might have a role there. That it is it so that there is something that early numeracy learning and motor skills learning share? Is it something that they need to concentrate and not take all this coming outside, but kind of focus and remember what they were doing before and so on. So that's why I still don't want to throw EF out of that equation in a sense that it's, but the role of physical activity, at least in this age group, I think is less than the motor skills in that sense. So the skills learning, so how they learn to start, for example, hit the ball, it's not easy, as you know.
There's one more question I couldn't see over there.
Hey, Pirjo. Here.
Yeah. Oh.
So we are colleagues here from Helsinki, so we're going to continue this. So I have lots of things to talk with you about.
This is again very hard question.
But there's a question I think the others might be also interested. So you did a couple of reviews on early numeracy skills and physical activity. I'm wondering, did you come up with measurements about development of geometry, fundamental understanding of movement in space, and space and geometry are closely related, and lots of early mathematics research is kind of bypassing geometrical basic understanding, and I think that's very fundamental for early mathematics learning to understand shape and space as well. So I'm wondering if you have something to say on that part.
There is because we come from the side of learning difficulties. So we try to focus on those skills that predict the later development most. So that's why we often kind of say that, okay, measurement and geometry is not so relevant because we don't have longitudinal evidence saying that in children who are performing low, the measurement and the geometries are important, but the others, counting and relational skills mostly are. So that's why we have mostly ignored them, not saying that they are not relevant for all kids or average performing kids, but we are focusing on the learning difficulties side. So we haven't included them, and I don't actually remember if we even saw them in doing our review. But I can come back to that information for you.
My question is about social aspect. I may miss something, but in your intervention, children get intervention alone or they're in group, and maybe some influence of the observation of the social environment, I guess.
Thank you. You got the point. I didn't say it. There were small group activities, meaning that there were children were in groups of 5 to 8 kids, and they were during the average preschool day. We had a logbooks for teachers, so we have kind of information if they have noted something that didn't work. But as far as I remember, there was nothing this kind of big challenges with the composition of the groups, but they were all tried to be low-performing kids, young kids, but we had no data about, so no videos, for example, seeing that how it all turned out. It's only logbox. Sorry for that.
Okay, well, thank you very much for your attention and questions, and I'd like to thank our keynote speaker one more time. Thank you very much, Professor Pirjo Aunio, for your talk today.